Civil Engineering Material Science, Lecture 2, Metals and Properties of Materials. In the first slide here, there's just a basic introduction to the module. In other words, which materials are used, etc. Cast iron, and what an important part carbon plays in steel. I'll talk about this a bit later. Then a bit about material properties, talk about porous materials, why it's not the strongest, but is good for thermal insulation, and how important durability is. Next, the difference between tension and compression. It's important that you know and understand the difference between the two. These are the most important material properties: strength, hardness, ductility, stiffness, elasticity, and durability. And here's how we work it out. Essentially, this is a tensile test, which you'll be doing in the labs. The material is subjected to a continuously increasing load. It expands. Record the force and the extension, and then plot a graph of load against extension. Here you can see a video of the tensile test. Also, you'll be doing this during your first lab session. And this is what a typical load extension graph for steel looks like. Next, stress and strain. This is vitally important. You know what the difference is. Stress is force over area, which equates to load over cross-sectional area, which is in millimeters squared. That's stress. Strain is equal to extension over original length. And that equates to change in length over original length. The next graph is typical stress-strain plot for carbon steel. Again, it looks exactly like a load extension graph. Here we have the yield point, the linear and the non-linear part, or the safe and the unsafe part. Other things we can extrapolate from stress-strain graph is the level of stiffness. This is given by the Young's modulus. It's in the elastic region of the graph, and the non-linear part is the plastic region. And at the end is the yield point, the end of the straight line. This is the onset of plastic deformation. Now, comparison of materials. Here we have metal, glass and plastic, and we can see plastics are weaker and have a lower Young's modulus than metals. However, they are very ductile. Ceramics and glasses are very stiff. However, they're also very brittle. More on comparison. The area under stress-strain graph tells us how much energy must be carried out to break the material. Therefore, the higher the energy or area under the graph, the tougher the material. Metals are the toughest, and they're ideal for load bearing for steel structures. Now, just to recap, stress-strain graph. Here we have the yield point, transition from elastic to plastic, and that separates the linear and the non-linear part. The top is the UTS, which is the strength of the material. Next, hardness. This is essentially the resistance to indentation, and it is proportional to the strength of the material. Of ductility, how easily it is to permanently deform a material. It's change in length over original length times 100. It has no units. You can see in the following diagram, typical brittle and ductile material. On the left is typically ductile, and in figure B, typical brittle material, which has a linear part only. Next, elasticity. This is how easy it is to stretch a material in the elastic region, and is determined by the stiffness. The value of stiffness is given by the Young's modulus. This is determined by the gradient of the linear part of the stress-strain plot, and we can now see a comparison of different materials. See, steel is stiffest and latex rubber is the least stiffest. Durability is how long a material will last. And this, the list of different durable materials. Next, of metals. All metals are classified as ferrous or non-ferrous. Ferrous is based on iron, non-ferrous is not based on iron. 1 times 10 to the power 9 tons of metal is produced every year. 90% is iron or steel, ferrous, and the other 10% are other metals which are non-ferrous. Now, talking about ferrous metals, examples are steel, which is iron and carbon, cast iron, which again is iron and carbon but contains more carbon, wrought iron, which isn't used much, is essentially pure iron, and stainless steel, which contains a lot of chromium, which is quite expensive. What are the properties of steel? It's strong and cheap, very stiff, very strong in tension, very ductile, not resistant to wet corrosion, it's very dense, and not very fire resistant. Here we have a graph of 4 different types of steel. The high carbon steel has high strength, low ductility, and the low carbon steel has lower strength, high ductility. And just for elaboration, the 4 strengths of steel, and we can see that the Young's modulus remains the same for all steel samples, irrespective of carbon content. Therefore, the effect of carbon on steel is that it increases strength, increases yield strength, makes it harder, reduces ductility, and does not affect stiffness, or, in other words, Young's modulus. Now, non-ferrous metals, firstly titanium. It's the strongest steel, it does not corrode, it's half as light, but it's very expensive. Therefore, it's only restricted to high-risk applications, i.e. the aviation industry. Aluminium, it's very light, it's very ductile, it's also very flexible, and furthermore corrosion resistant, but it's not as stiff as steel, and it has a very low melting point. Therefore has poor fire performance and cannot be used structurally in buildings. Lead, used in sheet form and roofing. It's quite dense. It's alloyed with tin to form solder for electrical plumbing applications. And it's also rather flexible. And it has a low melting point. Next, copper alloys, used mainly for plumbing and electrical applications. It has excellent corrosion resistance, hence it's used as radiator pipes, mixed with zinc to give brass, mixed with tin to give bronze. These are used extensively in plumbing and electrical fittings. It has excellent electrical conductivity and high thermal conductivity. And finally, zinc, used in roofing and cladding, has excellent corrosion resistance. It's used for galvanizing steel, as it provides a thin protective coating. It's a cheaper process than stainless steel, and by clicking on this link we can see our galvanizing video. Okay, at this point I conclude the podcast. Thank you for listening